Here we have to integrate sine square x. This sine square x can be rewrite as 1 by 2, take it outside because it's a constant, 1 minus cos double the angle 2x dot dx. Now we can easily integrate it. 1 by 2 is constant. You don't have to worry about it. Integration of 1 will be x and integration of cos 2x will be sine 2x upon the coefficient of x, which is 2 plus c is your final answer. Ta-da! Similarly, if you have to integrate cos square 4x, then what will we do? We will use the formula of cos square theta. Yes. So this cos square 4x can be rewrite as 1 plus cos double the angle, or we can say 8x upon 2. Now we don't have to worry about this 1 by 2. Just take it outside. Integration of 1 is simply x plus integration of cos 8x will be sine 8x divided by coefficient of x, which is 8 plus c is your final answer. Ta-da! Here we have to integrate sine cube 2x plus 1. So whenever we have to integrate sine cube theta, we have to use the formula of sine 3 theta, which is 3 sine theta minus 4 sine cube theta. We can make sine cube theta subjective. So we'll get 3 sine theta minus sine 3 theta upon 4. So we can rewrite this sine cube 2x plus 1 as 3 sine 2x plus 1 minus sine triple the angle. So 6x plus 3 whole divided by 4 dot dx. Now we don't have to worry about this 1 by 4. We just have to integrate 3 sine 2x. 3 is constant. Integration of sine 2x plus 1 will be minus cos 2x plus 1 upon coefficient of x, which is 2, minus integration of sine 6x plus 3 will be minus, or we can say minus minus become plus cos 6x plus 3 upon coefficient of x, or we can say 6 plus c. For further simplification, we can multiply 1 by 4 within the bracket. So we'll get minus 3 cos 2x plus 1 upon 8 plus cos 6x plus 3 upon 24 plus c is your final answer. Ta-da! Here we have to integrate sine 3x into cos 4x. So to get one of this form, let's multiply and divide by 2. So here we'll get 1 by 2 integration of 2 into cos 4x into sine 3x, because 4x is greater than 3x. Okay, now this is the second form. So let's apply the formula of 2cs is equal to s minus s. So here we'll get s minus s, or we can say sine minus sine. In first angle, we have to take summation of angle 4x plus 3x, or we can say 7x. And in second angle, we have to take difference 4x minus 3x. So it will give us x dot dx. So here 1 by 2 will be as it is. Integration of sine 7x will be minus cos 7x upon coefficient of x, or we can say 7, minus integration of sine x will be minus cos x, or we can say minus minus become plus cos x plus c. Ta-da! Here we have to integrate sine 4x into sine 8x, which can be converted into minus 2ss form. So let's multiply and divide by minus 2. So you'll get minus 2 sine 8x into sine 4x, because 8x is greater than 4x. Okay. So here we get minus 2ss form, which can be converted into c minus c. So here minus 1 by 2 will remain as it is. Here we'll get cos minus cos. In first angle, we have to take summation of angle. So we'll get 8x plus 4x will give us 12x. And in second angle, we have to take 8x minus 4x will give us 4x. So we are ready to integrate. Minus 1 by 2 will be remain as it is. Integration of cos 12x will be sine 12x upon coefficient of x, which is 12, minus integration of cos 4x will be sine 4x upon coefficient of x, which is 4, plus c. Ta-da! You can consider this as your final answer. Here we have to integrate cos 2x into cos 4x into cos 6x. Let's try to simplify cos 6x into cos 2x, and for that we have to multiply and divide by 2. So here we'll get 2 times cos 6x into cos 2x. For some time, this cos 4x will be remain as it is. Now, let's simplify our 2cc form into c plus c, or we can say cos plus cos. In first angle, we have to add the angles, or we can say 6x plus 2x. So here we'll get 8x. And in second, we have to take 6x minus 2x. So we'll get 4x. Your cos 4x still remain as it is. Now, for further simplification, we have to open the bracket. Cos 4x will multiply with cos 8x will give us cos 8x into cos 4x plus cos 4x into cos 4x will give us cos square 4x. So let's give separate integration. So now let's integrate one by one. So to simplify first term, let's multiply and divide by 2. So here we get 4 and 2 cos 8x plus 4x. It will be converted into cos plus cos. And as we know, in first angle, we have to take summation of 8x and 4x. So we'll get 12x. And in second, we have to take the difference of 8x and 4x. So we'll get 4x. Now, in second term, this cos square 4x can be rewrite as 1 plus cos double the angle, or we can say 8x by 2 dot dx. So we are ready to integrate. This 1 by 4 will be remain as it is. Integration of cos 12x will be sine 12x upon coefficient of x, which is 12, plus integration of cos 4x will be sine 4x upon coefficient of x, or we can say 4. Now, in second term, 1 by 2 will become 1 by 4, and integration of 1 will be x, plus integration of cos 8x will be sine 8x upon coefficient of x, or we can say 8 plus c. You can further simplify and we will accept this as the final answer. Ta-da! Here we have to integrate sine x, sine 2x into sine 3x. So let's convert into minus 2ss form. So here we have to multiply and divide by minus 2. So here we'll get minus 2 sine 3x into sine x. Let's say sine 2x will be remain as it is. Now let's simplify this minus 2ss form into c plus c, or we can say cos plus cos. To get the first angle, we will add 3x and x. So we will get 4x. And in the second term, you have to take the difference of 3x and x. So you'll get 2x. Your sine 2x still remain as it is. Now, for further simplification, we have to open the bracket. So sine 2x will multiply with cos 4x, will give us cos 4x into sine 2x plus sine 2x into cos 2x will give us sine 2x into cos 2x. So to simplify first term, we have to convert into 2cs form, and in second term we have sine 2x cos 2x, which can be simplified using the formula of sine 2a. So here we need 2. So let's multiply and divide by 2. So multiply by 2 and divided by 2 will give us 1 by 4. So minus 1 by 4 will remain as it is. Now let's simplify first term, which is in the form of 2cs, will be converted into sine plus sine. In first term, 4x plus 2x will give us 6x. And in second term, 4x minus 2x will give us 2x. Now, in second term, we have 2 sine 2x cos 2x form, which can be converted into sine double the angle, or we can say 4x dot dx. So here we are ready for integration. Integration of sine 6x will be minus cos 6x upon coefficient of x, or we can say 6, plus integration of sine 2x will be minus cos 2x upon coefficient of x, which is 2, plus integration of sine 4x will be minus cos 4x upon coefficient of x, which is 4, plus c. For further simplification, we can multiply minus 1 by 4, will give us cos 6x upon 24 plus cos 2x upon 8 plus cos 4x upon 16 plus c is your simplest and final answer. Ta-da! Here we have to integrate cos x minus sin x upon 1 plus sin 2x. So as you can see, we have trigonometric terms with different angle. So let's try to convert this 2x in terms of x. So we have to reduce the order of sin 2x. So let's use the formula of sin 2x. So we can say this cos x minus sin x upon 1 plus this sin 2x will be converted into 2 sin x cos x. Now, in denominator, we have cos x minus sin x. So to get the perfect square of cos x plus sin x, we have to convert this one in terms of sin square x plus cos square x. So here, your numerator still remain as it is. In denominator, we get a square plus 2ab plus b square form, which is actually perfect square of sin x plus cos x, right? Sin x plus cos x is your inner function, and its differentiation is also available within the multiplication of dx, which indicates that we have to assume sin x plus cos x is equal to t. So differentiate both the sides, we will get cos x minus sin x dot dx is equal to dt. So we can modify our integration as this cos x minus sin x dot dx will become your dt, and here we have 1 upon sin x plus cos x the whole square will convert it into t square. So here we just have to integrate 1 upon t square, or we can say t raised to minus 2, which is t raised to minus 1 upon minus 1 plus c, which can be simplified as minus 1 upon t plus c. To get the final answer, just substitute the value of t, which is sin x plus cos x. So minus 1 upon sin x plus cos x plus c is your final answer. Ta-da! Here we have to integrate sin x upon sin x minus alpha. We should get x minus alpha in numerator, and for that, let's add and remove alpha in numerator. So here we'll get sin x minus alpha plus alpha, and your denominator will be as it is. Now this x minus alpha can be considered as a, and this alpha will be considered as b. So here we get sin a plus b, which can be simplified as sin a cos b plus cos a sin b. So let's simplify our numerator. Sin a, or we can say x minus alpha, and cos b, or we can say cos alpha, plus cos a, or we can say cos x minus alpha, and sin b, or we can say sin alpha. Still, your denominator will be as it is. Now, for further simplification, let's give individual denominator. In first term, sin x minus alpha will cancel out. We will get cos alpha, plus in second term, this cos x minus alpha upon sin x minus alpha will become cot x minus alpha, and sin alpha will be remain as it is. Okay. Integration of cos alpha will be cos alpha x, plus in second term, sin alpha is constant. We don't have to worry about it. We just have to integrate cot x minus alpha, which is log mod sin x minus alpha, plus c is your final answer. Ta-da!